this example, we're gonna write the expression as an equivalent expression in x only. The tangent of the inverse cosecant of x over 2. The inverse cosecant of the x over 2 is an angle. So we name it as an angle theta. The main problem from the tangent of the inverse cosecant x over 2 becomes the tangent of an angle theta. Set it aside, work on the notation that we use to represent the inverse cosecant of x over 2. So since the theta is the inverse cosecant of x over 2, it means cosecant theta equals x over 2. Recall the cosecant is the reciprocal of the sine, which is the opposite over hypotenuse. So then the cosecant gonna be the hypotenuse divided by the opposite side. With this relationship, we complete the right triangle diagram, locate an angle theta. So the cosecant of the theta as x over 2 as a hypotenuse over the opposite. Hypotenuse is x, the opposite is 2. We're going to complete the right triangle diagram by finding the adjacent using the Pythagorean theorem. The Pythagorean theorem will give us the adjacent as the hypotenuse squared subtracted by the opposite squared, or we can write it as the simplified form of the square root of x squared minus 4. Now, the right triangle diagram is completed with all three sides. Back to the problem. Since we are going to find out what is the tangent of an angle theta, where is an angle theta is the cosecant of the inverse cosecant of x over 2. With the relationship, the tangent is opposite over adjacent, and then use the right triangle diagram to find out those two sides. The opposite is 2, and the adjacent is square root of x squared minus 4. Therefore, we got the expression in x only that represent the tangent of the inverse cosecant of x over 2.